Dear friends, welcome to the course on electronic packaging and manufacturing. So far you have learnt about many aspects of the packaging, and in last few lectures you have learnt about the thermal management, which is a very important aspect of the electronic packaging, and in this and the coming few lectures you are going to learn about the importance of vibration analysis. Now, in this lecture, these topics will be covered. First, the importance of vibration analysis. Second, damage caused by vibration and shock, and the third one is the vibration and shock testing. Now, let us first come down to the design aspects of electronic packaging, which is just kind of a recapitulation. Now, there are several aspects of design. First one is the connection, which is very important, then thermal management, which is equally important, manufacturing and maintenance. I do not have to say anything because it is very important part of the packaging, and then comes the shock and vibration, and finally ergonomics and environment. Now, in these lectures we are going to learn about the shock and vibration aspects of the design. Now, let us first learn where the equipments or the electronic equipments experience shock and vibration. There are three places in which the vibration is encountered. First is at the place of manufacturing. Consider a product which is being manufactured, and it is a complex product. So, therefore, it requires many places to be handled, and from one place to another place there is a transportation, and at times maybe accidentally the equipment may get dropped by mistake, or there are other during machining also it may be subjected to some vibration. The second phase comes during transportation from the manufacturing or from the manufacturing place to the final operating place. It has to be transported by road, by ship or by air. So, during this transportation process there may be the vibration which will automatically come because of many factors, like during road transport, unevenness of the road profile, on the sea because of the undulation caused by the sea wave, or in air transport because of the vibration of the aircraft. And finally, at the place of operation. Now, at the place of operation there may be situations where the equipment has to operate in a very harsh environment. For example, during the military appliances, the equipment is placed maybe at the missile or in the fighter craft, which is moving at a very high speed and it is encountering vibration. So, this is a very harsh environment. Sometimes the equipment may be placed in a less harsh or the benign environment. For example, a very quiet place like a computer terminal, which is at the office place. So, therefore, the vibration level of vibration there which is its facing is quite small. So, depending upon the place of operations, the requirement of vibration will be different. Now, then comes, why do you study the shock and vibration in electronic equipment? Now, there are many things or many damages which could be caused by vibration and shock. One is the collision of the components, then the breaking of components due to large stress, and the failure of joint due to fatigue. I will explain with a very simple example which all of you might be following. An equipment which is taken to be in the form of a box, and there are other components. I will explain in later classes that this could be modeled in a very simple situation as a spring and a mass, although there may be some damper which may be always present, damping element, and suppose that this is the box which is the Now, this box, suppose it is vibrating. Now, let us say that this is resting on a table and this table is vibrating with some excitations. Let us consider this excitation to be the simplest excitations, that is harmonic excitation, and as a result of that, this mass which is m, that will have some relative motion with respect to the box. So, this will have movement x, which will be a function of time and it will move back and forth. So, there will be vibration in the mass. Now, what may happen if this frequency it actually takes certain value, then what may happen that this relative motion, that is z, if I consider z to be x minus y, which is the relative movement, that means if this is the z. So, it may happen that the z undergoes very large deformation. Then what will happen? This mass actually this will start moving upward, and this relative this distance will change. Okay. Now, if the level of vibration is quite large, then it may so happen that this distance becomes equal to 0, and at the extreme situation when this distance is trying to become less than 0, then the collision may take place. So, this component may get collided with the outer casing, which may damage the component. Second part is that this spring is actually, let us consider this to be an helical spring. So, this spring now undergoes deformation, and this deformation is cyclic in nature. That means, it can have both compression and expansion. Now, all of if you know that this spring actually what happened, if you consider a part of the spring, then whenever there is a deformation, then actually this spring has experiences kind of a torque, and this torque is fluctuating torque. So, in the when this torque is fluctuating, and this torque will have the same fluctuation frequency omega, which is the driving frequency. Now, if you have a fluctuating torque, then what may happen, that there may be a fatigue failure. That means, when there is this stress, the torque will develop shear stress into the spring. This shear stress will be fluctuating. Now, if there is a fluctuating stress, then it may so happen that the material can fail because of fatigue. Also, it may so happen that the displacement of the spring or the deformation of the spring is so large that it can reach the ultimate breaking stress, and the spring can also break. Although it rarely happens in a physical spring, but remember, we are considering the electrical equipment, electronic equipment, where this spring is not like a helical spring, but it will have some other kind of structure. Due to large stress, large static stress, it may reach very high the breaking stress, and then it may break. But the fatigue failure or the breaking is most prominent in the joint. I will explain this with the help of a simple example. Now, if you consider a cantilever beam which is massless, it has the Young's modulus E and the second moment of area I. Maybe we consider the length of this beam as L. Now, as it vibrates, suppose it is vibrating with certain amplitude. Now, as it vibrates, this beam gets deformed. The beam will deform this way, that way, and when the beam deforms, then what will happen at this point, that means near this joint, the stress developed will be quite large. Here what will happen when the beam is moving upward, then there will be compressive stress developed, and compressive stress developed on the upper surface, and the lower fiber will experience tensile stress. And when it is going up, when it is going down, just the reverse is taking place. That means compressive stress will develop in the bottom surface, whereas the tensile stress will develop in the upper surface. Now, when this beam is moving back and forth, then what will happen? The top fiber and the bottom fiber will experience alternating stress with very high magnitude, and there it can fail because of the fatigue. Okay. The stress reversal is quite large at the topmost and the bottommost point, and here these are the potential points where the fatigue failure may take place. So, this is these are the mainly the damage caused by vibration and shock, and now by this time you understand pretty well that these are very important aspects, the vibration and shock, because it can easily break the components. So, we must take proper care just to eliminate the vibration and shock, which will be the subject matter of our study for the coming few lectures. Now, vibration and shock testing. So, you see that the vibration and the shock testing is quite important because of the following reasons. That is, it can help to take the remedial steps before shipment. Now, what is that? Suppose that an equipment is designed perfectly. Okay. So, there is nothing wrong in the design, but during manufacturing process there may be some flaws which may be introduced. Okay. And these flaws these flaws appear in the form of micro cracks. When the equipment is in operation, then from this micro crack the larger cracks may develop. So, these are known as the fatigue cracks. So, fatigue cracks can develop and it ultimately may lead to fatigue failure. Now, vibration and shock testing, if properly done, we can find out the defective component and eliminate this defective component. We can take proper measures to again take the corrective action, so that these defective components can be made again better. So, before shipment the vibration and shock testing can help. Then it can increase the lifetime of the component. So, it is very much understood that as I said that before shipment, if the proper precaution is taken, then the lifetime of the component can be enhanced, because the components which passes the test for of shock and vibration, then it is expected that this lifetime goes longer. Also, in the vibration and shock testing, we can take care of both vibration and cyclic thermal loading. Now, in thermal management, you have learned how the thermal loading takes place. Now, the thermal loading can be sometimes cyclic in nature. That happens when the switching machine is switched on and switched off. So, therefore, suddenly the temperature increases, and then after switching off the temperature goes down. So, there will be a thermal loading. At the same time, there can be the vibration loading, because when the machine operates, then there will be some certain atmosphere, some environment where the vibration will be generated. for example, when you are working in a computer, then the fan is working, and that fan may induce vibration into the components. So, this vibration, both the vibration load and the cyclic thermal load can be present in the equipment during operation. Now, in the vibration and shock testing, the both this can be taken care. That is, we can have a testing where either we can give only the vibrational load, or we can give the thermal load, or we can give both. Now, when the both vibration and cyclic thermal load they are incorporated, then it is found out that the lifetime of the component it increases. Okay, I'll tell you how the thermal loading, the cyclic thermal loading is taken care. Now, the test requirements for a vibration and shock testing. Now, operating condition is one of the most important part for the test requirement. That means, there are certain operating conditions which do not which are not very harsh. As I said, the example is maybe the very home appliances, electronic equipments where the vibration level is low, but on the other extremities there may be the equipments which will operate in a very harsh environment, like in the military operations. The electronic equipments have to work in the harsh environment, and there the testing requirement is different. Then the orientation of the critical component. Orientation of the critical component. So, normally an electronic component, it is placed on a holder which is mounted on the shaker, and this holder actually the electronic components are placed during testing. So, this is the board and the electronic components are there. Now, usually the orientation of the vibration is actually such that the equipments move perpendicular to the plane of the PCB, but it also depends upon the component. There may be some components which are prone to failure in certain preferred directions. In that case, actually we can change the orientation of this holder and place it in such a way that that particular orientation is given vibration. So, depending upon how many axes of vibration is how many axes are to be vibrated, the vibration time actually changes. Normally, if there is only one axis which is to be vibrated, then normally the 10 minutes it is vibrated for 10 minutes, and then it is seen whether the failure is taking place or not. Now, if the preferred axis is given, then what will happen that we vibrate it in all three axes, and these 3 axes are given vibration for let us say 5 minutes. So, therefore, it is not vibrated for each axis 10 minutes, but 5 minutes given vibration for one axis, and then other axis also for 5 minutes and so on. So, cumulatively it is 15 minutes of vibration it is given. Now, that is the aspects of orientation. Now, the third point comes the complexity of the product. Now, depending upon the complexity of the product, that means a product can be of a few chips, or maybe hundreds or thousands of chips. So, depending upon that, the requirement of testing is different. Now, I was talking about the thermal cycling. Here it is quite important, that is if you have let us say an equipment an equipment, it is given a vibration load, let us say of certain frequency omega. Also the thermal cycling is given, but this thermal cycling is of less frequency. So, this is the thermal load and this is the vibrational load. Now, if this is a simple equipment, then maybe one complete cycle is good enough, but if it is complex one, then we can have, let us say, 3 or more cycles. So, this is one thermal cycle, time period for the thermal cycle. So, we vibrate it and this is the vibrational, this is the mechanical vibration and this is the thermal cycle given. Now, if the complexity of the equipment increases, then instead of one cycle we can give 2, 3 or more cycles, and it has been found out that with the complexity, suppose for a very a small equipment having a few number of chips or the components, then one thermal cycle, suppose this is the number of thermal cycle, and this is the failure probability. So, if the component has if the equipment has less number of components, maybe after 1 or 2 thermal cycles the lifetime increases or the failure decreases. But if you have a large, a very complex system, maybe we have to go for a number of. So, this is the complexity. As complexity increases, so we will have to go for number of thermal cycles. And here this thermal cycles, this takes from minus 55, around minus 55 degree Celsius to 55 degree Celsius. This is the limit, the lower limit of the cycle and the upper limit of the cycle. The frequency is quite slow, because you know the thermal process is actually diffusive process. So, therefore, it cannot be as fast as the mechanical vibration, but this is how the thermal cycle is taken care. Also during the shock, it is the shock is actually, it is like vibration, but the shock has the loading which is kind of abrupt loading. Like here we have the equipment, the vibrational loading is like this kind of steady state loading, whereas the shock loading is something like this. So, the force depends on T in somewhat this kind of manner. Now, when does it happen? For example, if the box which is containing the equipment, it drops from a height h, let us say, somehow it gets dropped, then what will happen? The content material here, it actually experiences kind of sudden force, because it initiate this potential energy is transferred to the kinetic energy, and this kinetic energy suddenly goes into the equipment in the form of the vibrational energy. So, suddenly a huge force is developed here, and then this force gets transmitted. So, this is the shock. Now, you can very easily understand from this, that is the during shock, actually the fatigue is more than fatigue, it is the catastrophic failure or the breaking which is predominant, because suddenly the stress component within this the equipment component, this builds up and it may lead to failure, or or the surface can be get damaged and so on. Now, the test criteria here for the shock testing can be different depending upon the weight of the equipment. If it is a very heavy weight equipment, then normally the height h is small, whereas for the lightweight equipment the testing is done with a large amount of height. So, that there are certain protocols which is standard in the ASTM protocol, you see ASTM, or there are military standards which are followed during the testing process. The testing is this protocol is set by the procurer. For example, the military persons, they want to procure the component, they set up the design the testing protocols, and depending upon the testing protocols the manufacturer has to comply with. So, this is one aspect of shock and vibration which the manufacturer has to take care. Now, remember in this you have learned that the shock and vibration is a very important aspect, because it can damage the system, damage the components. This damaging can be due to the high stress or the high fluctuating stress, or that may be because of the interaction between the thermal loading and the vibrational load. Now, testing is very important. Through testing we can enhance the lifetime of the component many folds, and that is why testing is to be thoroughly done for the electronic components. With this I end the lecture here. Thank you very much.